Let's take a moment to review some important features of power series. First, here I have written a power series centered at x equals 0. So a power series centered at x equals 0 by definition is f of x equals the terms here that you see where c0, c1, etc. are constants. Then the second one, f of x equals, this will always be true as long as the function has continuous derivatives at 0. So anyway, let's take a look at an example. So we looked at a function, let's say f of x equals 1 over 1 minus x. We recalled that that was geometric, where a1 was equal to 1 and r is equal to x. We recognize this as the sum of a geometric, and this comes out to be 1 plus x squared plus dot 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 plus x to the n plus dot dot dot, and we said that it will be true for x between 1 and -1 with a center of 0. Okay, and that form here, this form here, clearly meets the definition of a power series centered at x equals 0. In this next example, f of x equals sine of x, we raw constructed this. In other words, we used this feature here, so we found f of 0, f prime of 0, etc. to construct a series for sine of x, and it turns out that becomes x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial plus dot 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 plus -1 to the n x to the 2n plus 1 over 2n plus 1 quantity factorial plus dot dot dot, and through the ratio test the interval of convergence was for all values of x, and the center of that was also x equals 0. And so that fits this form here, but it must also fit this form here because this is the definition of a power series centered at x equals 0. It turns out that the C1 coefficient would be 0. I'm sorry, the C0 coefficient would be 0, the C2. All the even degree terms would have a coefficient of 0, but it still fits this protocol here. And so centered at x equals 0 has multiple meanings. One is it's written of the form. That's one way to say that it's centered at 0. The other way is actually look at the interval of convergence and say, wow, that middle is 0. And then a third way to think of a center of a centered at x equals 0, is to take a look at the graph. So that's what I want to do right now. So if I type in, this is Graphmatica, if I type in y equals the sine of x, everybody should know what that function looks like, as follows. So now if we take the some of the terms of the series, let's say y equals x, that's the first non-zero term of the power series for sine of x, that would be a linear approximation. So it looks like that. And that line, blue line, would be approximately the sign for values near the center of 0. So this linear approximation was constructed starting at x equals 0 and then moving outward. If I look at y equals x minus x to the power of 3 over 3 factorial, which is 6, then I graph that, then you see we have this cubic which fits closer to the sine of x, and it was centered at 0. It started at 0 and is working outward. Let's add some more terms to this. So the next one would be plus x to the power of 5 over 5 factorial, which is 120. And then we get this magenta looking purple curve, and again it starts to smoothly, I'll follow here, kind of more closely follows the sign and for a longer period of time. I'm going to go ahead and do one more. Minus x to the power of 7 over 7 factorial, which is 5040. Graph that. and it just continues to go on and on and on in that fashion. Now, if I took a billion terms, it would be the sine of x exactly until you got way far out on either end, and then it would spring up or spring down. And if I took an infinite many terms, it would converge to the actual sine of x curve. Now, if we look at a power series that's centered at x equals a, something other than 0, then the definition of a power series centered at x equals a is where I have starred. The only difference is I replaced x, or x minus 0, with x minus a. And then the second version here is the way we will construct a power series. We haven't done one like that yet, but let's give you an example of a function, f of x equals 1 over 1 minus x minus 3, which, as we said in the earlier lesson, that this is geometric. a1 equals 1, the common ratio is x minus 3, and now I write out the terms of the series. 1 plus quantity x minus 3 plus x minus 3 squared plus dot 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 plus x minus 3 to the power of n plus dot dot dot. And that will converge for the absolute value of x minus 3 less than 1, which leads to 2 is less than x is less than 4 as the interval of convergence, which then has a center at x equals 3. The one meaning of it is the middle of the interval of convergence. The other meaning of it is we see the form this is written as, which is this form here, which by definition says a power series centered at x equals 3. Now, this next lesson is going to investigate some power series of this variety, and we'll talk a little bit about the graphs later. I want to say one last summary. Power series that are centered at x equals a are considered Taylor series, and power series that are centered at x equals 0 are considered Maclaurin series. Now, a Maclaurin series is also a Taylor series. It's a special type of Taylor series, one where a is equal to 0.